morning. So, ladies and gentlemen, once again, we meet again on Friday. Nice to see you all. And I wanted to say how pleased we are today in CITRIS to welcome our friends from Hitachi. They've been a long-time supporter of the university in many, many ways. Nate Oda here spent many hours cutting his teeth on Hitachi new chips, which is kind of a different kind of project to what we're hearing about today, which speaks to what a huge organization Hitachi must be. And John's work associated with the Berkeley Wireless Research Center is especially focusing on these home environments, which I think especially interesting to all of us here. There's plenty of amateur electronics people in the room that like wiring up their house for crazy kind of projects and making their place more interesting. So I think this future talk on how our future homes might look like as we walk into them and they respond to us as we walk in the front door and burst into life. John has the vision for that. So in our traditional way, I'd like to welcome him with a round of applause and a round of applause.
Thank you very much, Paul. My name is John Simons. I'm Laboratory Manager of the Wireless Systems Research Lab in Hitachi America. I'll describe a little bit about Hitachi's organization in North America, especially the mission of my lab and motivation. Discuss some of the application scenarios that we are faced with today. Talk a bit about our research activity, standards work, and prototyping. Finally, I'll summarize some of our academic collaboration. So Hitachi America was founded in 1959, so it's been in North America for quite a while. It's a wholly owned subsidiary of Hitachi Limited. We work very closely with Hitachi Japan. Hitachi is trying to globalize, but it's still not globalizing to the extent of some of our competitors, and that's why one of the reasons my lab was created last March. So we've been in existence for only 1 year. About 5,000 employees in North America. My office is in Brisbane, California. We have 3 labs in North America. Hitachi America has sales divisions and affiliated companies. My division is one of the internal organizations. But we work closely with some of the other groups, especially Hitachi Global Storage, Hitachi Data Systems, Hitachi Computer Products, and Electronic Products divisions. Our chip company, Renesas Technology, spun off a couple of years ago with Mitsubishi. We have hundreds of affiliated companies in North America. So my lab was created in March last year. Our focus is advanced broadband wireless systems, and our first project is reliable video over wireless LAN. Basically, we want to connect our consumer products in a wireless fashion within the digital home of the future. Hitachi is very strong in RFID. You mentioned a new chip, 3G systems, but in wireless LAN we're very new to this area, so we hope to catch up. Some of the other laboratories include the Storage Area Network Solutions Lab, Santa Clara, looking at storage network solutions. We have a harmonious computing project, also Santa Clara, looking at server technology and standardization.
What does that mean? Harmonious? It's singing computers? Or?
This is bringing together enterprise computers into a single platform. And in the Detroit area, we have the Automotive Products Research Lab, looking at clean engine technologies, car information systems, telematics. So my lab's mission is to enable new wireless video markets in digital home of the future, especially in the area of robust wireless video entertainment, and mostly focusing on the home, but it could translate also to the enterprise as well. Initially, it's fully funded by our central research organization. It's a research project with Hitachi Japan. And the overall project goal is to achieve over a gigabit per second wireless LAN. Our specific goal is to improve quality of service. That's the reliability over which video can flow over networks. For multiple televisions, and we're starting some next generation standards projects within IEEE 802. Also involved in prototyping, I will explain that later on, and doing some joint development with our business units who eventually will hopefully fund us to actual products. So what are the motivation and goals? Consumers are acquiring and trying to manage mountains of digital data, images, music, and increasingly video. So they know about home networks. They want to share this information around the house. They want to enjoy this content easily, conveniently, across different devices and locations in the home. Wi-Fi, which is IEEE 802.11, is becoming ubiquitous for voice and data. And we think that it's a clear choice for video as well. Now, this is not to say there will be a hybrid solution. Maybe there'll be a wired, wireless backbone, or a wired backbone with wireless in each room. Ultra-wideband may play a role in this. But we think if we can achieve wide-ranging wireless LAN, that will be the solution of choice.
Why do you think 802.11 is the clear choice? Are you talking about 11N, or what part of 802.11?
Well, we think the physical layers have improved tremendously, including 11N. However, the upper layer, as I'll explain, the upper layer software has not evolved at the same rate. 11N is perfectly capable for some short-range applications, we feel. We feel that within 5 years, though, that physical layer will be replaced by a gigabit per second physical media. And on top of that, we can put a video-specific infrastructure. So our goal is an infrastructure using 802.11. So the work will be done with industry and with IEEE, I think. So we want to make 802.11 the foundation. It's a natural evolution from data-driven routes to a video-centric media. We want to build on the medium access control MAC foundations for wireless video. We want to consider video-specific MAC improvements, so we want to bring the MAC higher up in the network stack. And we want to leverage other emerging standards like 802.11v, K, resource management, resource control, which have not so far been included in products. So who is using digital media today? Photography is the biggest segment. Mostly older people. They have more desire to buy PC media centers. Gaming is the second biggest. It's these people are actually paying for games, mostly downloaded. They have very high penetration in digital cable and television. Television owners, DVR owners, there's TiVo owners, very big population and growing, and they're highly interested in accessing their stored data in other locations of the home. And they're very interested in buying video on demand, pay-per-view, IPTV kind of services. Digital music, also very big. These households actually pay for music. They're using download services like iTunes, of course, subsidy. Home video is still in and the computer video is still in the early adoption mode, but a strong presence in 18 to 24-year-old age group. And children, presence of children in the household is also a key indicator for home video. Computer video, this is the emerging market. This is the market that we in Hitachi feel will grow into a mainstream behavior. So which PC applications in demand? This is from Parks Associates. Interestingly, owners of PCs are very interested in using them as DVD players. That's the biggest category. Initially, a couple of years ago, it used to be music, and now they're interested in playing DVDs. Then they want to use their computer as a photo server, and then as a video server. So we're seeing things go upside down. Music was the initial driver. Now we're seeing moving pictures as the driver. Luckily for us, we have DLNA, Digital Living Network Alliance. Hitachi is a member of this. And this is bringing together industry to start to solve some of these problems of interoperability. We tend to have three islands: the mobile world, the PC internet world, and the consumer electronic broadcast world. The goal of DLNA is to bring these together to a single infrastructure. And they're specifying devices like music players, cameras. The adoption of DSL and cable is a driver here. Home networking, as I mentioned, wireless and wired Ethernet coax cable. And they are defining some terms. They're defining digital media servers like set-top boxes, computers, home stereos, broadcast tuners like a set-top box, even mobile phones. And they're defining the playing devices like Hitachi televisions, the stereo home theaters. So having defined these two roles, they're now talking about usage scenarios, how they interact with each other. And ultimately, the goal is to have these products interact seamlessly in the home. Hitachi, we are more interested in HDTV at this point. So we feel HDTV is poised for rapid growth. Had a slow start several years ago, limited programming available, very high prices for television sets, and there's little awareness of the quality of high-definition pictures compared to standard. You never saw standard TV next to an HD TV and saw a side-by-side comparison. And interestingly enough, DVD was driving sales. People love DVDs. It's enhanced quality for AT progressives, so they could get a very nice DVD experience on an HD TV. So it's changing a little bit now. There's more HDTV programming, so we're seeing HDTV sets go over $8 billion projected for this year. There's more programming, the prices are lower, the quality perception is a little bit more widespread. Gaming is going to be driving this. Xbox has its minimum quality is 780 progressive, which is very, very high definition. Seeing new compression formats, DivX HD, Windows Media, high definition. So we think about 2008, a couple of years from now, will be the turning point, and we'll see this spike even more rapidly. So this shows the three levels: high definition level, enhanced TV level, standard definition. So what are the video over wireless applications that we see in Hitachi? We are mainly interested in premium content distribution within the home. We feel if we can solve this problem, then we can probably solve some of the other potential applications. So premium content is digital TV from a service provider, video on demand, pay-per-view, IPTV content. And it will be entering the home through, we envisage a video server device with a built-in access point, sending content to remote displays using single hop direct link transmission. Of course, personal content distribution has to be supported as well, hopefully from the desktop computer. Portable devices will be coming into the home. That is another area. We're not so interested in that, but we have to deal with personal video capture, sharing, and storage. And again, network gaming. Network gaming requires very low latency for control and image and high definition quality. But our focus initially is on this premium content distribution. This is our idea of a...
what's the main technical problem then that you see that need to be solved there?
Well, it's doing these multiple channels simultaneously. In the UK, they're asking for up to 4 or 5 HDTV channels. We have to go through multiple walls, and we have to be 100 feet. This has to work seamlessly throughout the house.
So what's the aggregate bit rate that you're looking for out of the transmitter from the box?
Well, each station has to receive 20 megabits per second. That's the kind of worst case scenario. This is a multi-user environment, so we've got data as well. We've probably got several voice communications going on in the house as well.
Do you contemplate placing 1 or 2 small repeater stations? It solves the problem going through multiple floors, multiple walls, or is that sort of out of the question?
I think that would add too much latency. From our discussion in standards bodies, that is in discussion, but it introduces latency. If consumers will adopt that, it may be the way to go. The other thing is just use a wired network to each room as a short-term solution.
For watching TV or watching video or video on demand or watching DVDs, latency doesn't seem to be a problem. Or do I miss something?
Well, if 2 people are watching the same channel, it's nice to have them synchronized, especially people, they roam from one room into the kitchen, for example. They're watching TV in the living room, they go into the kitchen, they switch the TV on, they don't want to be any latency, echoing.
Yeah, I mean, suppose there's a second latency there.
Yeah.
Do you think that's a problem?
Second's not a problem. When you go to England, sometimes the digital audio broadcasts,
Yeah.
depending on the box you buy, can be up to 7 seconds latency.
I see.
So each manufacturer will have different gadgets and different chipsets in their boxes. I'm not saying we have to be. I'm not saying we need strict.
Well,
I'm not saying we need
asking,
strict
we don't know
synchronization.
what the key issues are. That's why I'm asking.
But one of the usage scenarios is walking between rooms and having music just follow you around a home. I know
Okay.
Jan Rabai has been
definitely.
talking to me. If you have DirecTV today and you have 2 sets going, you put it on the same channel, you can notice a latency. I don't think we're going to solve that problem, but
Andrew, do you want
so yeah, repeaters, that could be a midterm solution, having these, but I just don't know if consumers will allow that to happen.
Dan?
For everything except the cell phones, are you looking at Powerline stuff as opposed to wireless? I mean, it seems that you can.
I'm skeptical about Powerline, basically because the interference
Okay.
it generates, the whole house becomes, especially these light dimmer switches, cause a great deal of interference. So that's why but we're not ruling out any. In the midterm, there will be a hybrid solution, maybe Ethernet to a room, and it could be ultra wideband. We're saying ultimately, Wi-Fi makes the best sense. If we can solve it within 5 years, then it would be the ultimate choice. So yeah, 20 megabits per channel, quite easy. Has quite a high latency, jitter. And there are other scenarios as well. We're talking to Nortel about enterprise video conferencing, corporate broadcast, training, education. We're talking to Boeing about in-flight entertainment. This is a very dense environment with lots of multipath issues. They're talking about supporting up to 20 or more displays with a single access point. They have wide aspect displays. They have HD TV, at least in first class cabins. They are talking about unicast of movies, because people tend to pause movies and go to the restroom and come back. But they will multicast weather information, news clips, for example. We're talking to the BBC. They're interested in wireless TV studios, where it's a very noisy environment, and these digital TVs can kick out about 50 megabits per second. So now we come to some of what is the existing technology? The existing technology is 802.11. It's improved steadily over the years with MIMO, diversity, improved medium access control with 802.11e. We're even seeing fledgling cognitive radio functions, carrier sense for collision avoidance, dynamic channel selection, transmit power control. So it's evolving steadily. However, we still feel that quality of service support, especially for high definition video, is lacking. 802.11e and the Wi-Fi's subset wireless multimedia provides only basic quality of service. we want to achieve end-to-end quality of service.
Can you be more specific? What are the individual factors in quality of service that you would like to achieve and that are lacking?
Yeah, I'm going to have a couple more technical slides. So our conclusion, it remains the best effort, data-driven technology. Large overheads, there's no guarantees for latency or jitter, no sharing of traffic information, no end. So we feel, however, it's a good foundation on which to build. So what are the important requirements? Throughput. We need to support 3 or more high-definition streams. 8211N may solve this, we think, for short-range communication. Security, content protection. There's security of Hollywood content coming into your house and security of your own, home movies. We were talking to Fox TV, and they had some very specific requirements about encryption that can be used in the home network. And for the usability, installation, discovery, and maintenance, we don't want to have our TVs get returned or our consumer electronics get returned because they just can't be set up. But our focus is the critical requirement of reliability and quality of service. In other words, it must look and feel like a wired experience. So we started by developing some simulation models, and we did some throughput analysis of 8211E. I'll explain that. We came up with some new priority schemes, which is some of the things we noticed were lacking in 11E. We came up to some other solutions for interframe spacing, random interface spacing also to improve priority. Mode switching between direct link and access point mode, and also did a small project in bandwidth prediction. Some of these ideas are implemented in the core Mac. Some of these ideas are above the Mac. So we developed this model using OpNet. It's an end-to-end model. It supports the new HTTP traffic specifications. We've included some 802.11e QoS. And we have some channel models for A, B, and G, and we have some information about 802.11n as well. So this is kind of growing this model and using some of our benchmarking. And so we can have the complete MAC scheme, have the physical layer, and we can come up with some nice information on related to queuing models and HCC architecture. So throughput analysis our goal was to find out how far could we go with 802.11e and find the performance bottlenecks and the performance of some of these features. And it turns out that we're looking at the acknowledge and no acknowledge mode and using the EDCA function, enhanced distributed channel access. With this turned on, it provided the best throughput at all packet sizes. So that was some information that we put into our further activity. Priority schemes, that's one area that is lacking. Video does not require 100% error-free throughput, so we want to take advantage of that. So we proposed a mapping scheme between the application specified bit packet error rate to the 11E priority. So if you're talking about data, then we wanted to really have the lowest error rate possible. But for video, we can apply different forward error correction schemes, and we can achieve the higher error rates without impairing the video, the actual perceived quality. So that was one idea for priority one that we've worked on. Another problem is interframe spacing. Interframe spacing is used in traditional 802.11 to implement priority levels. If you have a large interframe space allocated, your priority is low. If it's short, you have a higher priorities. But this breaks down when you have multiple HD TVs, all streaming content at the same time. We get collisions. So we did some experimentation by making this random within some limits. And our simulation showed we can reduce collisions and improve delay throughput for all classes. And one of the benefits was that the global delay even for voice was reduced. And when we do our simulations, we're looking mainly at video, but we have to look at best effort data, video, and voice to make sure we have no negative impacts. Another research area that we spent some time is direct link and access point mode switching. The current Wi-Fi technology, you can do direct link, you can do access point mode, but you have to set this up at the beginning of a session. Our simulation shows that direct link is better in most cases in terms of throughput and delay. However, especially when the display is a long way away, we do want to use the access point as a throughput mechanism. In other words, use it as a station to get further range. So we want to select basically direct link mode most of the time, unless we need range, and then automatically we can switch to access point mode. And one of the other areas that we're looking at is traffic shaping using rate prediction. Without bandwidth prediction, scheduling is bursty. Most MPEG streams have variable bit rates. So if we can predict the size of transmission, we can do better traffic scheduling and shaping, which will end up in less packet drops, especially for video. We published some early theoretical results. We have to study this in our wireless LAN simulation. And ultimately, we feel a cognitive solution will emerge, probably in a decade from now, but we're very optimistic about cognitive radio technology. We feel that eventually the home media gateway will be like an airspace management system. So this management system will allocate frequencies and bandwidth to the source devices and the sync devices, which will have point-to-point communication. Most of the control will be via this home media gateway, but the data will be sent directly. So that's our vision of kind of a long-term solution. As far as standards, we're looking at the 802.11 wireless next generation group. We're talking to several other companies. We want to create a new MAC standard for high definition video. This will be a kind of subset. It will be physical layer independent. And we're going to propose a study group in 2006, probably in May timeframe. We do expect there will be another physical layer within five years or so. I think 802.11n is a great breakthrough, but we can improve on that. And our goal for standardization is, yes, as I explained, we have some core MAC improvements, extensions, but we also want to take a look at error concealment, bandwidth prediction, even content protection and encryption. What is the impact of that on QoS? Real-time video quality assessment. We're talking to Intel about this. They have some technology for quality assessment of video streams. If we can do this in a real-time fashion, we can use that input to the medium access control. So we've done some prototyping using PCs, capturing over-the-air HDTV, and then sending it around wirelessly, and trying to measure the quality of the transmission. And we are starting next month more prototyping project related to a wireless set-top box. So it would be a wireless video server, connects to the outside TV sources. It would do transcoding of content to a local hard disk drive, live or time-shifted content distribution. We have this working now with 3 Ethernet connections, and we want to support 1 to 3 wireless channels using 802.11n, or probably a pre-11n solution. And we hope to have this ready by CES January next year. Academic collaboration. We're working with Berkeley Wireless Research Center, Professor Nicolay. And we're also working with Stanford Professor Goldsmith. She's doing some research on throughput optimization, MIMO systems, and some cross-layer strategies. Working with John Chaffee on wireless LAN resource management. So we are trying to get inspiration from academic institutions as well. So that's a brief overview of our wireless activities, and I'll be happy to take any questions.
Dan, you were burning to ask a question earlier. Do you want to jump in and go back to that?
Well, how much, so we look at energy a lot here, and in terms of just power consumption, when my house is disconnected, how much higher is my energy bill going to be? I mean, what are you looking at in terms of energy usage for such a seamless environment? It seems like it would be pretty high.
Well, they're all going to be tethered. They're all tethered devices, fixed devices.
Right.
You mean the electric power consumer?
Yeah,
the whole
I mean, because it's purely anecdotal, but so I don't have a TV right now.
Yeah.
Right? And my energy bill dropped by $20 a month.
Wow.
Yeah.
That's interesting.
Yeah. So that's so when I'm thinking I have 5 TVs that are all streaming HD at the same time.
Yeah, but wait till you get a dryer. Watch it. Wait till you get married. No, that's right. Even these connected devices, we have to look at power consumption.
That's astonishing that a TV would suck up $20 a month without energy.
That seems a little high. Actually.
Was it
Yeah,
on?
I don't. You know.
How much TV were you watching?
Not that much, but so I big TV. There's a TV and the Xbox and whatever.
I see.
If it's a media PC, it could easily be taking up that much power.
Yeah. Was it a media environment? I mean,
Well,
with Xbox and
yeah, I guess
the
an
VHS,
Xbox is an equivalent of the media
I
PC.
see.
and you had them all on wait mode, right? While you were looking up.
And I would turn it off. I mean, I know that Andrew has this set up now. And
My power bill's through the roof.
Well,
Ron Hoffman believes that this is the next big crisis, that these home entertainment centers take much more than a refrigerator, and much more than a new refrigerator too. They're kind of like a 1940s refrigerator in terms of what they're taking. I can't remember his exact data, but
so we should
Reese,
start
do you
plugging
know
these
the
things when we're not using them, right? It would save a lot of energy.
just last. Well, we're going off on a wild tangent, but last week after the seminar, I rushed down to BWRC where there was a group from the Energy Commission talking to John Wilson. They were really trying to drive a CITRIS project where, number one, there's the consumer awareness that in everybody's house there's random toothbrushes, cell phones, general wall warts sticking there. And if you add it all up for your power screwdriver, for looking at your garage, yada, 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 there's equivalent of a refrigerator grinding away with all those small things. And then and again, we're still on this wild tangent, as we go up to these media centers, they're consuming something, something like an old refrigerator. But that's, Andrew, isn't that right? Oh, Lisa.
If you have a media PC, just a Hewlett-Packard or Intel standard Windows Media PC, if you have it not in deep sleep, that is recording videos, recording shows, that kind of thing, it can easily be consuming 400 to 600 watts.
400 to 600 watts. That's a lot.
But it's just like leaving your desktop on. Same thing.
Even more.
Yeah, even more than it. Well, what's the desktop?
about the same,
It's about,
but this is hard drives running full speed all the time.
yeah.
Yeah, so in addition to power, interference is also a problem. You have all these devices on microwaves. We have to engineer this entertainment network for the worst case scenario, which is, a high-tech household, crowded.
Anyway, yes, Colin.
On that scheme now, there's the central box that plays such an important role. If that central box catches a virus or gets down for some other reason, then everything is dead in my household.
Right.
So there are other schemes that try to put much more of the intelligence out to devices and have redundancy and a network of several intelligence hubs. With the idea that one goes down, you don't lose anything at all or very little. What is your thinking on those lines, and how much of a reliability can you guarantee to that central box?
Well, this box may be provisioned by the service provider, ultimately.
Okay.
So they can roll a truck and replace it.
Get like a RAID system inside or something.
We call it home media gateway, but your content eventually may be in the network somewhere in their service, in their data center. I know Quest is looking closely at that, so that instead of having a TiVo box with your own hard drive, which is prone to crash, it would be in the network. So, loosely speaking, this may not.
Okay, you build redundancy into the box itself.
Yeah, and if your disk drive is in their data center, they're backing it up. Some of these devices, especially TVs, we do not want to build in too much functionality into our TVs in terms of network connectivity. If that TV goes broken, you have to return the whole thing. So we have, you probably noticed, Hitachi Plasmas have external receiver boxes with a single high-quality cable to the display. So the displays can be mass-produced and the boxes can be manufactured separately.
So if the scenario is to have your multiple high-definition channels follow you around the house, and you're essentially pumping all kinds of bits into the air, the sensor network that's going to follow you around and tell the system where it is competing on the same ISM band, reasonably. How do you view the contention between the high-speed network versus the sensor network?
I don't think it'll be automatic, this following. It'll be nice. I think you'll press the stop button in one room, go to another and press the play button. But there will be sensor networks. They'll have to coexist. I know IEEE is looking at coexistence. And they're mostly using ultra-wideband, I think. There was sensor networks. So you're talking about a low bit rate.
No, it's in the same 2.4 gigahertz band.
I think 11N is probably, most of these consumer products are using 5 gigahertz band. The Japanese government recently allowed operation 5 gigahertz or channel bonding in 5 gigahertz. So it's actually probably going to look at 5 gigahertz where there's less interference.
Dan, you're bursting to say something.
A couple years ago, there was this really high-end installer for a system just like this, but based on older technology, called Pluto. I don't know if you're familiar with that, but they were claiming to deliver, obviously not to quality, it wasn't HD, but this kind of connected experience and then it would also do sort of room detection so that it would tie your cell phone into the, it's essentially if someone called your cell phone, the phone would only ring, your landline would ring in the room you were in, that kind of thing, and then you would have a portable TV, and it was a vision for this kind of setup. And I don't know and I'm guessing that they installed it in at least some very wealthy people's houses. I don't know if you can look at those as the earliest adopters of this kind of system.
We don't want to be too intelligent. We just want to get 3 or 4 reliable HDTV streams and make it look like a wired experience.
Were you familiar with
On
that?
top of that, we can do all the bells and whistles, like following you around the house.
Were you familiar with that, Pluto?
No, I wasn't actually.
Reese, do you know what that is?
Where was it?
It was called Pluto Networks. And it was a company, and they would install essentially early Windows Media PC servers, and they had just their own software layer on top of that that handles some functionality.
You're seeing some companies like Sonos for sound being able to provide very high quality using Wi-Fi, and they will guarantee synchronization in 2 or more rooms. So I think eventually you'll see the same thing for video. That's the equivalent. So when the throughput gets up high enough. And you see early products like Buffalo, Link Theater, and you've seen D-Link, some of these network players. Very, very good quality. Each using 802.11g.
Any more questions?
Most of those are tested in environments where there isn't other wireless traffic going on at the same time.
That's true. Well, I have 3 wireless TVs in my house, and I'm trying to test it as much as possible. It works fine for standard television, which I download.
Wi-Fi phones and Wi-Fi security cameras and
Exactly.
things like that.
See, that's the key point. This is a shared medium. We have to give priority and control access to these networks in the future. Alternatively, we use a completely dedicated network for video. That's another scenario. We use 802.ABG for data.
Andrew?
If you need another test bed, I can donate my place. You can always use it on more large screen TVs.
Yeah, today's just free lunch. You don't get a free HDD.
As long as you catch, you have to pay the power bill.
Yeah, I think for Andrew that would still be a small catch. I think it would still be. Yes?
What's the projected cost of such a system?
Well, today's network, like the Buffalo product, is $300, $270. So that's out of the range for the average person. So I think it's got to come down to like a TiVo price, $99 for the client side, and then the set-top box, it would be free probably from your service provider.
What's that screen in your office? Is that Hitachi? Any more questions? Everybody salivating at the idea of their house wired for TV in every small and large room. You can move from your sandwich to your couch to the bathroom, still watching a movie. It's a vision of the future. Sometimes I've checked into a hotel and there's a TV in the bathroom as well, which I don't have. It's kind of off-putting. I kind of get distracted as I'm brushing my teeth. Before I know it, I've been brushing one side of my teeth away. So, Reese, do you want to make the final question?
Well, this is much easier to do if you abandon real-time streaming HDTV, where you go for a lower bandwidth and you go for buffering in the display device, where there's latency. You can consume a lot less power. You can go a lot further distance and so forth. Is that the real-time streaming component? Is that a...
Well, it's important, and the content owners have limits, have restrictions on the latency. So if you're streaming something you've downloaded, then yes, you can use big buffers. But if it's premium content, they have requirements, not physical requirements, but contractual requirements around latency. So if, as I said, if we can solve the premium content case, then the other stuff will be pretty straightforward.
So it's a trade-off of digital rights management versus electricity consumption?
Digital rights management and encryption we have to figure out how does that affect QoS. I mean, it does affect latency if the algorithms are big, complex. I'm not so sure about power consumption.
Well, real-time means more.
We don't want to end up having these displays full of silicon that's doing a lot of encryption, decoding. We want to keep the solution as simple as possible from a system LSI viewpoint.
There was a recent study that showed that DRM in like an iPod can reduce the playtime by about 10 to 15%, just in decrypting. So
10 to 15%?
Yeah.
That's a lot.
That is very interesting.
Just in the laptop. One more final question? If not, then let's give John our.